Greetings everyone, my name is Lance. This is part 2 in a series on GPS. The topic of this video is RTK. The image we're looking at shows the general concept of GPS corrections, and it applies to both differential and RTK correction systems. What I mean is that there's a base station that monitors the signals coming from the GPS satellites, and it sends out some form of correction data to one or more rovers. That correction data can be transported in several ways, such as via satellite, radios, or over the internet. Differential correction systems commonly cover large geographic areas, so a satellite is a good way to get that correction data out to the rovers. RTK corrections are typically more localized. The further a rover is from the base station, the less accuracy it will have. This has to do with different atmospheric conditions at different locations. For this reason, radio links have been the most common way to transport RTK correction data. Typically, a base station will be mounted to a solid structure, such as a brick building or cement post, and a radio transmitter will be mounted up high on a tower to get the maximum range. One of the downsides to using radio links is terrain. Hills, trees, and buildings can obstruct a radio signal, meaning the rover won't get the correction data. The easiest way to resolve this is to use a radio repeater, which will simply relay the correction info. In the last few years, another option has started to be used, which is to use the internet to transport the correction data. Essentially, you would need an internet connection at your base station, such as a DSL line, and then an internet connection at your rover. Because your rover needs to be mobile, most people use a data connection from their cell phone provider. Of course, this requires decent cell phone coverage wherever you want to use the rover. This also eliminates the need to purchase radio transmitters, repeaters, and receivers, making the entry cost lower than radio links. Be aware that there will be a monthly recurring access charge from your cell provider for using their data network. The other major hurdle for RTK has been a distance limitation. Regardless how far you can transport the correction data, the position accuracy is going to drop the farther you get from the base station. The atmosphere is always changing, and probably a little different over your rover than it is over the base station. When using a single base station, the position accuracy of the rover is considered good within a 20-kilometer radius of the base station. At 30 kilometers and greater, a significant amount of accuracy will have been lost. This is usually rated in parts per million, or ppm. A ppm rating of 1 means that you will lose 1 centimeter of accuracy every 10 kilometers you are from the base station. People buy RTK systems for the accuracy, so when you lose accuracy, it kind of negates the purpose of buying an RTK system. The industry has come up with a method to link multiple base stations together, known as a real-time network. Transporting the correction data over the internet has really allowed this technology to grow. In this scenario, multiple base stations send their data to a central processing facility, which allows the system to create a map of atmospheric conditions. There are a lot of complex algorithms involved in this, but it allows for more accurate correction info at larger distances from the base station. It even allows the base stations to be spread further apart. As much as 70 kilometers between the base stations is acceptable. There are several ways to implement a real-time network, and different manufacturers have different ideas. The oldest method is FKP, but it's an odd one, so I'm not going to discuss it. VRS and IMAX are very common, and similar in concept, which I'll explain in a bit. MAX is the newest concept, which is what the industry will probably be going to in the future. Let's discuss IMAX first. When you connect into the system, it tells your rover that the base station it is connected to is whichever base station that is located the closest to you. However, all the correction data it sends to your rover is from the collective atmospheric map from the base stations around your location. For this reason, your rover needs to send its position into the system, periodically, so that the correction data can be calculated for your specific location. VRS, otherwise known as Virtual Reference Station, is similar to this, except that the system creates a virtual base station that your rover thinks it is connected to. The on-the-ground accuracy of VRS and IMAX is going to be very similar. Given a choice, the surveying people prefer IMAX, only because it is connected to a real reference station, and they like working with known locations. MAX is altogether different because the corrections are calculated on the rover instead of at the central processing facility. The system sends your rover correction data from each of the surrounding base stations, and your rover can then use all of that data to determine the best possible correction method based on satellite visibility and other factors. Because of this, processing load on the receiver using MAX correction data is considerably higher. Older receivers that can't do MAX will have to continue using VRS or IMAX. As for moving correction data across the internet, there are several protocols designed to do this. The one I'm most familiar with is called NTRIP, which stands for Network Transport of RTCM Data over IP. And I'm going to give you an example of this using a copy of GNSS Internet Radio, which is a free NTRIP client. And I'm going to connect into the Minnesota Department of Transportation network, which I've already configured with the IP address and username and password to connect in. And in the settings screen, there's a couple options here. Defaults are pretty good, but it has some options where you can send the data out to a COM port, log it to a file, etc. And it also has an option to set the GGA string, which is what's used. It's the latitude and longitude that are used by the VRS system, because the Minnesota DRT uses VRS. It's the latitude and longitude to calculate the correction data for my location. Now I'm physically in Iowa, so I'm just telling this system that it's got some latitude longitude that's somewhere in Minnesota. I don't really care where, I'm just looking at it from an example standpoint. Now on the main screen there's an option for mount point, otherwise known as stream. And since I've never connected to the server before, I don't have anything in the list. So the first time that I connect in, it connects to the server and downloads a list of all the mount points, all of the things, the different streams that I can download. And if you look through this list, it'll be descriptive enough to tell you what each one of these sources does. There are a couple sources that will supply data in a CMR Plus format, which is the data format that the data comes in, and there are two that are in RTCM formats. One is RTCM 2.3, and the other is RTCM 3.0. The two on the bottom also have GLONASS support, so if your rover supports GLONASS satellites, then you want one of the streams that sends you GLONASS data. If your rover does not support GLONASS, then you want one of these other two. And depending on what type of rover you have and which sort of correction formats it can accept will determine which of those two options you want. Typically CMR Plus goes to Trimble receivers and most everything else uses RTCM 2.3. Anyway, once you select one of these source types, you click Start and it will log in. This time it has to have a username and password. And then it sends my location to the server so that the server knows where I'm at and can generate correction data for me. And then the server will start streaming data back to me. This is correction data that you're looking at here in Hyperterminal. And it looks pretty cryptic. I can't understand it either. It's a binary format, so viewed in ASCII it's not readable, but that is correction data that your GPS receiver could use. Another format, for example, we'll try RTCM 2.3, which looks considerably different than the CMR Plus does. And you'll see that it logs in, sends a location again, and we'll start streaming that here in a second too. That's what RTCM 2.3 looks like. Hopefully this is a good demonstration. Obviously if you were connected to a real GPS receiver, you wouldn't be viewing the data, it would just be going direct to the receiver for processing. Hope this video was good. Enjoy it. Leave some comments if you got any questions or whatever. Have a good day. Thanks.